The session is going to be on the title of IoT enabled smart network. By Dr. Simar, Preet Singh, Assistant Professor at School of Computer Science, Engineering and Technology, Bennett University, Greater Noida. And Sir has published research papers in reputed journals like SCA Expanded Scope Index in various national and international conferences. His area of interest includes cloud computing, fog computing, Internet of Things, computer networks, and machine learning. And Sir has earned his doctoral degree at Tapar Institute of Engineering and Technology, Patiala, and also holds several specialized certifications, including like Microsoft Certified System Engineer, Microsoft Certified Technology Specialist, and Core Java. He had undergone a training program for VB.NET and Cisco Certified Network Associate. And Sir, we are looking forward to the session, and the session is yours. Thank you.
Thank you for the wonderful introduction. I welcome each participant to this faculty development program. I am Dr. Simar Preet from Bennett University, and today I am going to share my views on the topic Internet of Things, which is helping the smart networks to work in the growing technology. So the topic for today's session is IoT enabled smart networks. So this is the agenda that I will be covering out. So I will be starting out what the Internet of Things is, and then the statistical part of IoT, why this IoT is becoming more and more important in nowadays. And then the hands-on part, I will be working on the how to work with the Internet of Technology devices, how to work on microcontrollers. And this hands-on will be a very crucial one for a beginner to work upon. Since we are into the faculty development program, we have different faculties as well involved into another computing technologies, and how we can utilize this Internet of Things platform for the social well-being. So I will be discussing about one case study which is using the IoT devices for social well-being, and in that particular case study I will be trying to automate the machine learning algorithms. So that is what the agenda for the day is. Moving ahead with Internet of Things. So Internet of Things, what it is a network of physical objects, or we say that the objects are things over here, and these all objects, these all things, these are embedded into the electronic software, sensors, and network connectivity. So everything is embedded. So it formulates embedded systems also, which enables these objects to collect and exchange the data. So if we talk about the CCTVs, they are continuously fetching the video packets, the pictures, which is being fetched from the CCTV camera. The IoT, it allows the object to be sensed. The packets are being fetched. The sensor is working over there. So they are sensing it out. Some scenes are available. They are fetching the data. And this data is being controlled. It can be controlled by the edge of the network. It can be controlled by different technologies. It can be transferred remotely across the cloud computing part. So these controlled remotely across existing network infrastructure, creating opportunities for more direct interaction, integration between the physical world and the computer-based system. So these packets, these frames are being captured onto the computer, and they are observed and they are sensed, and we can perform plenty of there are research opportunities that we can help us in improving the efficiency, accuracy, and the economic benefit. So we talk about the Internet of Things and things all around. So what these things are in the real-time daily life. So things in IoT refers to a wide variety of devices. So these devices can be any heart monitoring implants, or it can be a biochip transponders, which is applicable on the farm elements. It can be any automobile. Even your smartphones is having plenty of sensors, built-in sensors in the phone. So these all comes under the things category. And when we connect all this becomes the Internet of Things. So these devices, these are useful for collecting the data, which will help the various existing technologies. And then this data, the flow of data between the devices is very much crucial, because there are plenty of hackers, intruders on the network. So how you manage that particular things, we have different fields, different branches. So I will be discussing about the technological developments also in this field. So IoT is required to automate everything. Today's world is the digital world, where we are working with the smart networks, smart homes, smart city, smart devices. So we want our tasks to be automated. So that's why the IoT is necessary. So Internet of Things, it is there to automate everything, control everything remotely. Nowadays, each and every appliance is being controlled remotely. So we are having plenty of devices which works automatically, or there are certain devices which we can operate it from the remote, or we can have time-based systems or some scenario-based systems also. So they are all together engaged in their activities, and these are the automatic processes. So look, data in the real time. If we try fetching out the data in the real time, if we consider...
Good afternoon, Professor. Sorry to interrupt you. Yeah,
No
the voice is not very much audible, Professor. Can you increase your volume?
Okay. So at my end, the volume is... Yeah, are you able to hear? Am I audible?
Yes, sir.
Yes, is
sir,
the
you're
audible?
audible, sir. Yes, sir, you're audible.
Okay, fine. So we were discussing about why this IoT is being desired. So if we take about the real-time scenarios, the traffic that is moving on the road, that is also managed by the IoT devices. We can have the roadside units. We can put on the traffic lights that can automatically operate according to the desired traffic. If there is the more traffic, they can automatically switch between different roads and all. So that all automation part can be handled by Internet of Things. So Internet of Things is basically dealing with the phenomena of act, sense, plan, and act. So sensors are sensing the data. Then the microcontrollers are thinking. We are providing some special capabilities to the microcontrollers, and accordingly they are acting. They are performing the actions. So that is how the communication handles in Internet of Things. So if we talk about the statistics of IoT, Internet of Things, in 2014, we are having 180 plus billion in revenue, and the managed services revenue is $86,919.93 US millions, and this all has increased to a higher extent in 2020. We have the managed services with $571,845.77. So you can see how much it has increased from 86,919 to 571,845. So it's a huge increase in this technology, Internet of Things. So if we talk about the devices, that is the continuously increasing as we are approaching with the years by years. So there is a huge increase in the number of devices. So this data represents the devices in millions. So this gives the huge rate of devices that are being increasing in the coming years. So forecast for global IoT from 2015 to 2025. So it is projected that in 2025 we are having 5.44 billions of global market share for IoT. So this is how the IoT is expanding to the highest peak. So there are emerging technologies as well, which is involved due to this high increase of the devices. So endpoint segments, if we talk about different segments that are utilizing this particular technology, we have utilities, government sectors, building automations, physical securities, automotive, healthcare, retail, information, transportation. So plenty of different sectors, and every sector is using this particular IoT, and the use is continuously increasing as we are expanding with the years. So if we talk about the applications, we have plenty of applications that are working on with the Internet of Things. The smart car, wearables, smart appliances, smart buildings, smart home, smart TV. So plenty of these applications you must have heard, all the smart, and all these smart applications are having their smart networks, and these are formulated with the couple of connections. We'll be covering out that part in today's talk. Then smart world. If we talk about the smart world, you can see all the connections that are available. So formulating a smart network. In the smart world, we are having different segments like air pollution, forest fire detection, wine quality enhancing, sportsman care, structural health part, smartphone detection, radiation levels, water quality, smart parking, golf courses, and plenty of other things are there in smart world. So all these things are interconnected, so formulating a smart network. So that's why IoT is being helpful in developing the IoT based smart networking, which formulates in their IoT applications. If we talk about another application with IoT products, we are having plenty of IoT products that are available in common market. So these are the list of few of them. The first one is the helmet sensor, then Amazon Dash, then Kingsa thermometer, connected cars, smart fitness clothing, smart running shoes, garden sensors, smart televisions, and plenty of others as well. So if we discuss about each one of them a little bit, the smart helmet sensor. So in this helmet sensor, we are having the IoT devices, the sensors being incorporated, which is having in connection with your mobile smartphone. So smartphone is connected with this helmet sensor with the help of a Bluetooth. And if you come across, this is easily available on the Amazon as well. So you can go and purchase also. Another IoT product is the Amazon Dash, which helps with your instantly reordering of your favorite products. You can use this device for reordering purposes. Kingsa thermometer is also based on IoT products, which gives you the temperature reading as well as it connects your doctor also. Then next is the connected cars. The future of IoT, if we come across, it's a huge expansion, and a huge future is there because the devices are being increasing. And these are the wordings of some of the famous industry persons. McKinsey and Company, it estimates IoT will be having 11.1 trillion impact by 2025. So how the industry is being increases, and this all is increased due to the increasing number of devices. Then Gartner assesses the total spend of IoT devices and services to reach to 3.7 trillion in 2021. By 2023, the average CEO will be responsible for more than 3 times as many endpoints this year. So that is what the Gartner says. The devices are increasing at a huge pace. And if the devices are increasing at a huge pace, the load on the network is increasing at a higher rate. As the load increases, it emerges with a new technologies, new paradigms are coming up in the market. We'll be discussing about what all new paradigms that are coming in the market. So when we thought of IoT, Internet of Things, we come across that how to deal with these smart networks, how to deal with smart technologies, how we can make the devices smarter. For that, we require certain components. We require certain microcontrollers, certain electronics part. And when we talk about electronics, the microcontrollers, there are a couple of microcontrollers that we can attach with the devices, and we can make the devices in a smarter devices so that we can have a smart network. This network can be at any place. It can be at the home, it can be at the office, it can be on smart traffic system, or anywhere you want to. You can have even your research projects also on this. So when we talk about making our devices smarter, we require the electronics, and in electronics we have certain boards. Some of them are the Arduino boards, and there are plenty of Arduino boards that are available for making the smart devices. The Arduino Uno is one type of board, another is Mega, then Yun, Micro, Nano, BT, Ethernet, and plenty of others boards that are also available. Then we are having even enhanced capabilities devices as well. The Raspberry Pi, which is having the inbuilt Wi-Fi device as well, and which is having huge capabilities to perform with the IoT devices. Then Node MCU, the recently emerged technology. It is a very small device, cheaper device, and it can be having the mobile adapter for its charger also. So there are plenty of advantages of using the Node MCUs. If you want to work on with Arduino IoT Cloud, we are having the IoT Cloud as well, which you can navigate to arduino.cc and then IoT homepage. You can work on with these devices in the remote fashion. IoT Cloud is available. So this is how the Arduino Uno device looked like. This is a microcontroller which is having the processor, the microchip, that is the ATmega 329P. So this is what the chip is, ATmega 329P. Then we are having, these are the digital pins. There are 14 digital pins naming from 0 to 13. On the pin number 13, we are having the inbuilt LED, that is L mentioned over here. This is your USB jack, this is your DC port. Then on the other side, we are having 6 analog pins, A0 to A5. And then in ground pins, there are 3 ground pins on this board, 2 on one side and 1 on the other side. Then we are having single 5 volt pin, 3.3 volt pin, reset pin, and certain couple of transistors, capacitors to formulate this particular complete board. So this is how the Arduino Uno board looks like. We will be working on with this board and how we can make the devices smarter, how we can make a smart network using this particular board, using the microcontroller in the Internet of Technology. So for working out on this board, there are different scenarios. The first one is you can buy this board. It is easily available on the Amazon and online sites as well. Even the electronic shop will be providing you with this board. But if you want to use your practicals for your research purpose, or you want to involve your students into the capstone projects or other type of projects, you can use the smart network, smart computing in the online fashion as well. To do so, you are having one web page known as the thinkercad.com. So this is the website. When you navigate to Thinkercad, so this is what the page will open. Thinkercad creates 3D designs with Thinkercad. So this is how it looks like. In this page, you can draw the circuits as well. You can draw the designs part also. So this is the platform where you can use. So if you are onto this platform for the very first time, you can create an account using the sign up option that is available on the right hand side. So you can click on the sign up. You can create your own personal accounts, or you can create the educator account, or this you can invite students to join that particular class if you are an educator and you are teaching this course in your curriculum point of view. But since we are not teaching this course, we can create the personal account. Then there are a couple of options that you can use your Apple ID if you are an iPhone user, or else you can use the Gmail account also, or you can sign up with your email only. So you can click on sign up with the email. You can go through the country. You can select the country as India, enter your birth date, and you can click on next, and you can put your email ID and password and click on create account. After creating the account, you can verify the email which you have filled over here, and after verification you can navigate back to tinkercad.com, create 3D designs, and then you can click on login. So next time when you are onto this page, you have created the account successfully, you can click on login, and when you click on login, it's asks certain options, whether you are logging to the personal accounts, whether you are logging as the educator, or you are having the student with the class code, or you are logging with the student's account. Since we have created the personal accounts, we'll be clicking on the personal account, and then the way out which you have created the account. If you have created the account with the Apple ID, you can sign in with the Apple. If you have created the account with the Gmail, the Google account, you can use the sign up with Google. Else you can use the option email or username. Since I have used the email, so that's why I opted the option as email. I entered my email, it prompts me for the password. I entered my password, and on successful validation, it takes me to my dashboard. So this is the dashboard of Tinkercad, how this page looks like. We have a couple of designs that we design into this part. So this is actually what all you have done into this. So there are circuits also, which the circuits you can design. There are code blocks also. The advantage of this platform is if anyone is afraid of doing the coding, then this platform provides you with the drag and drop capabilities. You can drag and drop the set of blocks, and automatically this platform will be coding for you. So if you are belonging to non-computer science background as well, but you have the keen interest towards automation, towards your developing smart networks, or towards the research on emerging technologies, you can use this platform where you can simply drag and drop, and you can have your code automatically done for you, and the activities and the things will be working for you in the manner you want. So in this, we are having the 3D designs and the circuits and the code blocks. So if you are engaged with the designs part, 3D design, you want to design some objects, or you want to design some frames, you can use the 3D design, or else you can navigate to the circuits part. These are the couple of tutorials as well that you are able to see on this platform. So you can navigate to the tutorial section for more learning. Since we are here to perform certain IoT projects, so I'm moving on with a new, and then it is giving me 3 options. 3D designs, if you navigate to 3D design, it gives you the capabilities where you can design your architectures. So I have selected 3D design just to show you out how it looks like. So this is the plane, and you can drag drop certain objects onto this plane, and you can perform the designing part of the objects. You can see this plane from all the 360-degree angle. So that's the advantage of using this platform, and you can design all your objects over here. So let's move back to the circuits part, which is there for the IoT section. So this time I am moving on with new and then circuit. On moving on with new and circuit, I am able to enter into the circuit section. So on the right hand side, I am able to see certain components. So these are the basic components. You can navigate to the all option so that you can see all components that are available within this platform. So these are the devices, these are the things that we were discussing out in the Internet of Things definition. So these devices, these things are used to turn any of the device into a smarter device. So let's see how we can do so. So we have gone through a couple of microcontrollers, couple of boards. So in this, we can search for the Arduino Uno board. So this is how it looks like. You can simply drag and drop the devices that you want, or the either way is you can search on this bar with Arduino or Arduino Uno or whatever device you want. So you can select and that particular device will be appearing in front of you. You can simply drag and drop, and this is all our working area where we will be creating the circuits. So if you bring this board alone and you navigate to the code section that is there on the top, and when you click on it, you are able to see the blocks mentioned over here. And certain couple of blocks are entered on the right hand side, and there are certain more options that are available on the left hand side part as well. So when you click on the blocks, you are able to see blocks plus text and text. So what this is, if I select only the text, it says that you are moving, you are closing the blocks editor and you are moving into the text editor. I said continue. So as soon I click on text, I am able to see certain piece of code mentioned over here. See, I have only taken the microcontroller over here in this site. I have not imported any of the devices yet, but I am able to see certain piece of code that is available over here. And what this code says, this code is a C++ code, and it says void setup. Then inside the void setup, it says pin mode LED underscore built-in comma output. And another is void loop, and we are having a couple of statements into this particular loop. So what this is, void setup and void loop. So these two are the functions that are available in this code. So while loop and while setup, these two are the functions that must be there in each and every program. Yes, you can create plenty of functions inside the program, but minimum these two functions must be there in any of the program or any of the project, right? So void setup, what this function says, this function includes all the setup configurations. All the setup configurations by mean is like here we are having the pin mode, and pin mode we are writing LED underscore built-in comma output. So what this says is this is the function, the setup is the function, and since this is not returning anything, so void is a data type, that this function will not return anything. So void setup, and inside this pin mode, it's also a function LED built-in comma output. So pin mode is a function that is used to declare which all pins we will be using in our project into this code. So whatever pins, whether it's analog pins or digital pins, we will be mentioning it over here, and then comma output. Output is the mode of that particular pin. If you are using a sensor, you can change this output to the input. Why so? Because sensor is fetching the data, and that data is acting as an input to this particular board. Am I clear? So that is why the pin mode is there, to define whether the respective pin will be acting as an input or it will be acting as an output. So that is, you need to define over here. If it is digital pin, you need to define the number from 0 to 13. There are 14 digital pins, or there are 6 analog pins as well. If you are working on the analog part, then you can define it with capital A0. Capital A0 means analog pin number 0. A1 is capital analog pin number 1. A2 is capital analog pin number 2. A3 is capital analog pin number 3, and so on till capital analog pin number 5. So you can see on this side there are capital A0 to A5. So these all are analog pins. You can see on the either side there are 0 to 13. So these are digital pins. For digital pins, no need to write D, only the integer digit will work. So if you go through this deeply, you are able to see some of the tiled signs mentioned over here in front of few of the digital pins. 3, 5, 6, 10, 11, 9. So these 6 pins are having the tiled sign in front of them. So this tiled sign signifies that these pins can be act as the pulse width modulator. PWD. So pulse width modulation task can also be performed if you connect with these pins only. For rest others, these will be acting as the 0 or 1. That will be a digital pin. Right? So let's move back to the code. So white setup, it is declared once and in the very initial beginning, and it is used to involve all the setup related files, right? Then white loop. So this is just like a for loop. This is a function named as loop, and this function is not returning anything, but this function will be behaving as a loop. It will continuously iterating this board. So whatever piece of code that you have mentioned within this particular loop, that will be keep on iteratively, recursively, that will be undergoing it out. But whatever code you have written in white setup, that will execute only one time. That will not be repeated again. That will be executed only one time when the program starts. And loop function, it is continuously repeating multiple times, several times the loop function will be keep on iteratingly. And this iteration is very fast, and it is not being observed very deeply by the human eyes. Right? So these are the two minimum functions. And for this board, if we want to do some programming, we have the LED attached to the pin number 13. You can see L is mentioned over here. So this is the LED light. So let's try writing some piece of code to make this LED glow. So how to do so? This LED is attached to pin number 13. So I am defining the pin number 13 and I want this LED to glow. I'm not taking any input. I want the output. So I am changing the mode of the pin mode function, which is having the syntax as pin mode, then the pin number comma mode. Right? So 13 is set to be as output pin. So we will be displaying, we will be glowing this and we will be turning off. In the loop section, what we will be doing is we'll be writing digital world, since we are passing the value of zeros and ones only. So digital word, digital values only. So that's why we have used the digital write. So digital write is a function which takes two inputs, that is the pin number and whatever you want to perform on that particular pin number. Whether you want to make that particular pin number high, high means 1, 1 means active. Or you want to make that particular pin number low, low means 0, means inactive. Right? So as of now, I want to glow the LED. So digital write, comma, LED number is 15. LED number is 13. We are having the inbuilt LED, and then we are putting it high. High means we are passing 1 to the pin number 13. And by passing 1 to the pin number 13, it will be having the high value and it will start glowing. Then we are having a delay function. Delay function is to hold that particular glow, the LED glow, but how long it can glow. You need to specify that within the delay, and whatever value you will be passing to the delay function, that value is in milliseconds. So 1000 millisecond will be equivalent to 1 second, because this loop iterates so fast that the changes is not being visible by a normal human eye. So that's why delay is necessary. So let's put a delay of 1500. The same way what I am doing is digital write. Earlier I am passing high to the same pin number 13, and now I am passing low, and digital write I am entering as 1500. This is the time in milliseconds, and delay is a function. So now we have completed up with the white setup part and the loop part. So let's try running this program to see the output. To run this program, you are able to see the start simulation option onto the right hand side. When you click it on, you are able to see certain light glowing over here. Are you able to see?
Yes, sir. Yes, sir.
Okay, great. So this light is glowing, and this light is the inbuilt light that is available on the Arduino Uno board. Why it is blinking? Because in the code I have turned high and low. If I remove this low part, if I remove this, that I only want this light to be glown all the time, I do not want it to stop. So now the LED will not stop. It will keep on glowing continuously. Right? So you can increase or decrease the time as well. Say if you want this glow to be even faster, then you can give it as 1 second, and you can again start the simulation. So the rate of blinking will be increased. So if you want to increase more, you can change this particular parameter accordingly. Right? So if I changing it to 1000 to 800 and I started the simulation, now you can see the glow has increased. The rate of speed has been fast. Right? So this is how we code on the Tinkercad, and this is what we are dealing with the inbuilt LED. But if you want to include certain different devices as well with this particular board, yes, you can do so. You can place the Arduino Uno board on one side and you can search for breadboard. So as soon as you type breadboard, the breadboards will be visible in front of you and you can choose any breadboard. Right? Any doubts so far?
No, sir.
Okay. So we'll be taking a small breadboard just so that it can be fitted onto the screen as well. And we are having this Arduino Uno board. Now, you can go with all and you are able to see plenty of components that are available in this platform. There is a resistor, capacitor, polarized capacitor, diode, inductor, even the push button is available. There are plenty of other components that are available. Even the sensors are also available. The ultrasonic sensor is there. The PIR sensor is there. Right. So if you want to have your projects available, you can attach the ultrasonic sensors on any platform and you can put the wires and you can code accordingly. So there are plenty of sensors that are also available. Since let's start glowing a single LED, how you can connect, how you can make the connections, how you can code and how you can glow that particular LED, that all will be going through. So to make a single LED glow, first of all, we'll be taking the LED and we can place it in anywhere over to the board. So this is the breadboard. So breadboard is designed in such a way that you are able to see the red line and the positive line on both the sides. So the red line and the positive line is the positive and negative of this complete breadboard. And the breadboards are designed in such a way that the last two rows, the complete rows, are connected together and the initial two rows, these are connected together. These all complete rows is having a one single connection, both at either ends, right? And in the in between, you are able to see the English alphabets A, B, C, D, E, E, F, G, H, I that is mentioned on the board. Are you able to see?
Yes, sir.
Okay. So these are the vertical connections, means if you connect any device over here, that will be having all the vertical access. This all is one single connection wherever you connect your device. So in this way, we use this particular board, and this is known as the breadboard, which is used to enhance our circuits, and we can design our complete circuit using the help of this particular board. LED part. So let's take the LED and put the LED in any section on this board. So when you place the LED on any of the section in this board, say I am placing it over say 11 and 12, right? Now you are having Arduino Uno, you are having the board. Now you need to do is the connections. To do the connections, we require two things. The first one is the neutral and the second is the phase line, the main line. So main line will be coming from the pin. Now which pin to select? Since it's only the LED, the load is just to pass 0 or 1, right? just to turn it on or to off. That's why we will be using digital pin only. Whereas in case if you want some continuous values, you can use the audio pins also, right? To use the digital pins, say we'll be using the pin number 9. I click on pin number 9. These are the digital pins, and I stretch it to one of the terminals. Right. So this is how I connected the wire. Clear?
Yes, students, please respond. That's clear.
Are you able to do so? Or should I repeat? Is this part clear? How we are wiring it out? I picked one wire. I will be repeating again. So how to wire this out? I am just clicking on the pin, which pin I want to connect, and I am scrolling my mouse to one end of the LED. Since the LED is attached with the breadboard, it is having one single connection on this pin number, on this 12. So anywhere you can connect. So I will be connecting over here, because this end is completely lying on this particular path, right? The second end, I will be putting it as a ground. So for that, I am selecting ground and I am connecting it with the other end, right? This is how the connections are made. You can do it in the reverse direction as well. Like the other end is there on pin number, on this 11 number. You can click this 11 and you can connect it with the ground either on this part or on the other part also. So you are having the ground pins on the other part. So if you scroll this, you are having the ground pins, 2 pins on this part as well. So anywhere you can connect. Right. So this is the connections, positive and the negative terminal. So we have made a connection with the board. Now the next task is to code for this particular LED that you have applied on the breadboard. To do so, make sure which pin you have connected this particular LED. So it's pin number 9. So I am going to code. So wide setup, okay, pin number 13, that is the inbuilt pin. Let's glow the inbuilt pin also. So pin number 13, and now I have connected an LED on pin number 9. So I'm writing pin mode 9, output. Right. Then wide loop, second function of the code. What I am doing is digital write 13, high. I am passing high value to the pin number 13. Then I am giving a halt. Say halt I am giving as 1500. Then again what I am doing is digital write 13, low. And again I am giving delay of 1500. So what this code is doing, this code is just glowing the LED attached to the pin number 13, and what is attached to the pin number 13, that is the inbuilt LED. So inbuilt LED is attached with pin number 13, that is glowing and waiting for 1500 milliseconds, and after that it is turning off, again waiting for 1500 milliseconds. again turning on, waiting for 1500 milliseconds, turning off, waiting for 1500 milliseconds, and this iteration is being repeated multiple times. So that is what is there in the loop part. Now we have incorporated one more LED with pin number 9. That's why we can increase this further code with pin number 9 instead of pin number 13. And what we are doing is we're writing digital pin 9, high, and then again some different time, say 1000. So this is 1000 milliseconds. Make sure this time can be different from the above time. No matters how much, this depends upon how much you want to put a delay between the instructions. Then this to right, now the LED is high, means it's glowing. We need to turn it off. 9, low. So you can give the delay as 1000, and that is the part in the loop. Clear? So if you start this simulation now, what happens is you can go through the code. Pin number 13 LED will glow. Okay, it's glowing. Then put in delay of 1500. Then you are moving a low value into pin number 13, which will vanish the light that is glowing, and you are putting the delay as 1500 milliseconds. Same thing you are doing for pin number 9 as well. You are glowing the LED and you are turning it off. So this way you can control the devices. So LED is just an ordinary bulb. It can be the CFL tube. It can be your normal 40 volts tube as well. It can be 100 watt, 60 watt, 0 watt bulb. Right? You can control its motion using the microcontrollers, using the Internet of Things devices, and you can make that particular devices as the smart devices. So IoT enabled smart networks. So plenty of devices on a single board will give you a complete network, which you, if you put that particular network into your home, that will be turning your home into a smart home full of IoT, full of sensors, right? So you can attach digital appliances as well instead of these devices. So you can attach analog devices as well, digital devices also, any type of devices. Even you can attach your high voltage ACs also with this board. And for if you are working on with the real-time scenarios for attaching the AC power, then you need a relay to attach the devices. Right? So this way how you can code. But if you are afraid of coding, then you can turn this part into more enhanced part by clicking on block section. So if you are not into the position to code, you can turn this into a block section. And when you click on block section, you can see certain blocks have appeared in front of you. So you can simply drag and drop the blocks. Like if I talk about the input, you want to give an input from some digital pin. You can give read digital pin. You can enter which pin number you have allotted out. If you have applied some digital device which is there for reading, then you can define which pin you have defined that particular device, and you can read the value. Say you have attached the ultrasonic sensor on pin number 7. So read digital pin number 7. That will be fetching as the input, and it will be reading the pin number 7. And if you turn around and navigate again back to the text, you are able to see certain changes in the code. If you click on code plus blocks and you enter a digital pin number, say 7, right? Since we have not attached, that's why there is no change. So let me attach one block. Say if this block is there and I am changing its value to 1000, you can see the value also changed in the particular code. Set inbuilt LED to low. I am changing it to high. Automatically the code is being changed. I want to wait for 1 second. 1 second is 1000 milliseconds. If I change this 1 to 2, then automatically delay changes to 2000. What is this 2000? This is 2000 milliseconds, which signifies to 2 seconds. If you are confusing between 2000 and 2, you can change this to milliseconds. Then you can enter 2000 over here. Here also the value will be 2000. So that's way you can, if you are afraid of coding part, you can simply use these controls. You can put the analog pin, digital pins, reading of the ultrasonic sensors from pin number, which pin you want to define. So you can put the inbuilt functions, inbuilt controls, inbuilt notations as well, and automatically your code will be compiled with, which will be a working code for you. You can put the block comments as well, like this is a webinar. So in the code, it will be automatically be there. So simply drag and drop features are also available. If you want to perform some computations, you can do so as well. So 2 plus 4 or so, wherever you want to use them out. So you can design your scenarios accordingly, and you can use the blocks only section, or you can use the blocks plus text part, or you can use the text part if you are comfortable with the coding section. So this is the sketch programming where you are embedding the code, and all this code is being incorporated into this chip. This is the 80 mega 328p chip that is placed on the Arduino Uno board. So once the code is there, no need of connecting the device to the terminal or the PC again, and no need to start the simulation. Simply plug it out and the code will be working for you. Like if I click on start simulation, you can see this wire is not connected, but as soon as I click on start simulation, this wire is into it, and you are able to see this charge sign as well. So this charge sign will show that the simulation has started. Moreover, you are able to see the simulation time on the top, and here the green color is there, which shows the stop simulation, means the simulation is running out. So you can create your scenarios, you can design your scenarios, and there are plenty of components that are available on this side. Even you are having the batteries as well. The 9-volt battery is there. You can use this battery to design your model also for this, for the working of this device. So same way, if you want to attach a switch in the circuit, say we have one light, and when we press the switch, that light will glow, and when we leave the switch, that light will turn off. So we have taken one switch from the component section. So this is the push button that is available. So I have attached one switch over here, and I have connected this switch to pin number 9, the digital pin number 9, other end to the LED, and another LED end to the ground, just to complete the network. complete the circuit. So in the code section, what I have done is I have used the same pin number 9. So output is there. So this is how I am glowing, and I am making the pin number 9 to high always. So there will be a current in the pin number 9 which will be delivered to the switch. Since the switch is off, so no current will be passed over to the LOD. But as soon when I press this switch, so the connection will be established and then the LED will be start glowing. So other end of the LED is attached to the ground to complete the circuit. So let's start the simulation. So if I click on start simulation, no LED is glowing. Now I'm clicking on this switch. I'm clicking on this switch, the LED glows. I'm leaving this switch, LED turn off. Click, glow, leave, off. So as soon and as much duration you want to turn the LED on, keep on pressing the switch, and when you are pressing the switch, the LED will be in the on state itself, and it will be off state if whenever you leave the switch. Since this particular code is turning on the inbuilt LED as well, that's why you are able to see this particular LED is blinking, because we are having the high value and the low value that is being passed into this particular inbuilt LED. So this way you can design your scenarios, you can have a couple of projects, experiments, and even use this platform to fetch the value from some sensors or from devices and pass on these values to some online cloud centers. ThinkSpeak is one platform where you can use, you can pass these values to ThinkSpeak IoT, and it's analytics platform. You can fetch the values in Tinkercad. You can use the ThinkSpeak to have the values, and you can perform further analytics on this part. And these are the couple of projects that are there, like the projects of environmental monitoring, students and educators, energy monitoring, smart farming. So you can go through these all projects. They are traffic monitoring, tide predictions, energy data analysis, weather stations. If you are interested for further research projects or further research publications, so you can perform your IoT-based projects, IoT-based scenarios using these platforms. Furthermore, to expand this, you can use Arduino.cc platform, which is a website which provides you with the software part also. If you are having the device and you want to work in real time with the devices by designing the circuits, just if you are working on with your capstone project, you want to show some model into your projects, or you are working on some patents, or you want to design some prototype of that particular patent which is based on IoT, you can download this particular tool, and you are having a real-time device. You can do the coding part, and there are documentation is also available. There are built-in examples as well, and the library examples as well. So there are plenty of examples which you can go through. So if we check about the blinking of LED, so blink the LED on and off every second. So these are the hardware required. So this is what the circuit designing is. This is how you can design the circuits. And this is the systematic schema of the circuit along with the complete code that is available and the program as well. So this is what we have already done, built-in LED, and you can define your pin numbers over here, and the program will be working in front of you. So this part you can navigate out. There are plenty of examples, plenty of reading materials, plenty of documentations that are available, which you can go through at your end. So Arduino.cc, it also provides you with the IoT cloud part. So if you navigate to cloud, You can have the IoT cloud, which is set up in minutes. So this provides you with the Alexa control, climate control, automatic lighting, and plenty of other features as well. So home automation and plenty of other smart technologies, smart devices that are provided with the Arduino cloud part. So there are plenty of things to explore. So this is how we can use the Arduino Uno boards. Further into the presentation part, we're having one microcontroller as the Arduino Uno. Another is the Raspberry Pi, which is also known as the future computer, which is there to perform the heavy duty task, and we can perform plenty of projects and research programs using this particular board. Since this is a very expensive board, it costs to near about 4,000 to 5,000 rupees in Indian price. There is a cheaper board is also available, which is being emerging up and is rapidly used nowadays with the name as Node MCU. So it is having an inbuilt Wi-Fi, and it requires the phone charger only for its operations to do. And it is also having plenty of digital analog pins. You can use this. The coding part remains same for the Node MCU as well as for the Arduino Uno part. For Raspberry Pi, we use its own OS that is being there in the Linux format. So that is available. And if you want to work on Raspberry Pi, you need its own platform. So raspberrypi.com/software. So it has the Pi OS. You need to install this Pi OS, and it provides you with the desktop edition as well, which you can connect out with the Pi, and you can analyze or synchronize the various codes that you can control the device. So this way you can work on with these microcontrollers to make your devices, to make your network smarter, which is the need of the hour. So this is how the coding interface that we have discussed. Then technological developments, use of these devices is there in almost every technology. If you talk about artificial intelligence, machine learning, edge computing, fog computing, cloud computing, robotics, augmented reality, virtual reality, and plenty of other technologies as well, in gaming also. So IoT is emerging, and it is having a huge use in the emerging technologies. How we can incorporate IoT into these emerging technologies? So let's talk about a case study which we have taken with the fog computing platform. So fog computing, it's a technology which is developed by Cisco in 2014, and it is basically consisted of multiple fog nodes that are arranged in a network which is known as the fog nodes, and these nodes are arranged at a one hop distance from the user. So due to these placement of nodes very close to the user, the devices, the data which is coming from the devices, these are handled, the analytics part is being handled at the edge of the network itself. So this data is not transferred over to the cloud for processing. The processing handles at the edge of the network so that the latency and the response is being faster. And the congestion on the network is also reduced. So this is the transformation area from cloud computing to the fog computing. Earlier we are having the devices sending data to the cloud, but now with the introduction to the emerging technology, the fog computing inside it, the analytics is being performed on the edge of the network only, and the traffic on the network is being reduced. So these are various communication models that are being used presently. So we use the cloud bridge using fog and edge computing model, where we have every communication technology involved. We have the Bluetooth communications, we have the radio communications, we have even the satellite communications, Wi-Fi communications, and the communications with the ISP providers and the wearable devices. So all these communications are there in current communication model. To manage all this, to manage the load, So basic thing is the devices are connected and there are so many communication modems. So the load on the network is a huge load. And in this case study, we worked on with the load balancing part and how to do the load balancing. These are the different types of load balancers that are available, and how this cloud load balancing is different between the fog load balancer. And in the case study, we worked on with the energy part. Energy efficient load balancing model is being used to propose a fog based load balancer. And these are the different comparison of tools that are available if you are planning to move on this case study for the simulators that you can use for this particular case study. So use of IoT devices with different technologies, as we are discussing about the technology of fog computing. So how you can use the IoT devices into this particular technology. So we have a improved load balancer algorithm, and which is deciding which best algorithm is there and which best optimization technique and design is being there. So design, if we take about the fuzzy load balancer, we have 3-level, 5-level and 7-level layers, and we perform the comparative analysis, and it comes out that the 3-level design is the better design for this case study. And for the optimization technique, we have the existing algorithm with the name as the teaching learning based optimization algorithm and the simulating annealing assay algorithm. And we propose the modified teaching learning based optimization algorithm, that is the MTLBO algorithm. And we found that MTLBO algorithm is the optimal algorithm for the designing and analysis of algorithm for improved load balancer. And we use this particular type of load balancer for the case study on social impact. And the social impact case study dealing with this is that to bring the people of informal economy, the people living at refuges or the high-end areas, to bring the informal economy people into the formal economy. So this is the block diagram of the case study. We have the qualification criteria, and we collect the data from different devices, sensors, and using the microcontroller, we analyze that particular data, and then we perform the trustworthy analysis, TWA, and based on 4 qualification criteria: inner circle index, fitness index for work, GDA and MLA, we perform the statistical analysis, and then we came up with the conclusion to design and to automate the things using the machine learning. Later on, the future is to incorporate this complete model into a web application or the mobile application, which automatically enhances the skills, enhances the people. And if that particular mobile application is there inside the individual, the informal economy can be considered into a formal economy, and that individual will also have the access to be a part of the formal economy, to have all the services that a formal economy people can avail. So this is the complete workflow, the assumption for the model, the data sets that have been used to design this particular model. So this is the system model of the fog-based communication model for informal economy. So we name this as FBCM I2E. So these are different IoT devices that have been used into this case study. Then the parameters that have been discussed and the mathematical prototype for designing this complete model, the fitness data set that we have used for this particular case study, and we find out the correlation matrix output. So medical ranges of different parameters which are used for the reference purposes, and then the results for the fitness data. Based on the fitness data, these are the results that have been obtained using the machine learning models. So 4 machine learning models have been used, and then based on these we worked on with the qualification computations, and the qualification computations have been computed out based on the call log analysis and the geospatial analysis, and we come across the results as that the cutoff criteria have been defined, and these are the values that have been obtained, and later on these values have been further analyzed to find out the cutoff criteria, and this was the computed cutoff criteria for different parameters. So if an individual that is being into an informal economy is having a geospatial criteria less than 623, less than call analysis less than 6, or modularity less than equal to 2.20, then that is not qualified, or you can use this qualifying criteria for deciding whether a person is in the formal economy or it is to be there in the informal economy only. So this way, the different technologies can be mapped up with the Internet of Things. You can use different sensors to perform the comparative analysis with other technologies, and you can design your scenarios, you can calculate, you can put those machine learning models, deep learning models into different technologies, and even you can work on with the energy analysis for different components using the equations, using the models that are available. So this way the IoT is mapped to multiple emerging technologies, and it's having a great scope, great emergence in the coming era, and it helps in formulating with the smart networks. And with IoT, even a small device can be formulated into a smarter device. So I conclude my session with the words as Internet of Things. It's a network of things embedded with electronics, software, sensors, and network connectivity that we have just seen. That we have a couple of devices, we have a couple of microcontrollers, all are embedded together. We connect using the wires, and we embed the software, the coding part inside the microcontroller, and accordingly the devices that are attached to that particular microcontroller, that behaves, collect the data and exchange the data. So statistical part of how the rapid emergence of IoT is being increases, that is also being discussed in today's session. Hands-on related to IoT devices using the Arduino Uno board has been presented. Just it will be acting as a key leading edge if you are if you are planning on to the moving on with the IoT domain, and you are not wondering where to get out the devices, and or you are into such regions where the IoT devices are not rapidly available, then you can use the Thinkercad platform to start working on with IoT. And then at the end, a little case study is being shown, which is dealing with the fog computing technology. And in that particular case study, the machine learning algorithm has been used to identify how the use of these devices, how the use of IoT is being involved into the social engineering work, and how a people living in the informal economy can be included in the formal economy, and they can enjoy their life, they can enjoy all the benefits that a normal formal economy people are enjoying. So that is the all. That is all from my side. These are the references that has been used for creation of these slides. Any queries, any doubts? I am leaving the house free for queries and doubts. Thank you, everyone. If you are having any queries, any doubts, you can discuss.
Yeah, participants, please feel free to post your doubts or queries, either in the chat box or you can directly ask the professor. Participants, any query? Please feel free to ask your doubts.
Devi Priya has asked that, sir, can you suggest us some online learning platforms for IoT? Yes, you can start with this Arduino.cc platform. You can navigate to the built-in examples and start working on with these examples one by one. They have categorized different examples into different modules. The basics ones are there if you are dealing with digital devices. So they are having the digital examples where they are using the digital right. If you are dealing with some current part, the analog devices, you can navigate to the analog examples that are given. So they have categorized different modules, like sensor-based examples are there where you are using the accelerometer, detector knock, then different types of ultrasonic sensor, rangefinder is there. You can use these all examples to design your scenarios. Like accelerometer are there in the mobile phones as well. So if you are reading this value, try reading some value using the accelerometer device that is there within the smartphone, how you are incorporating that particular sensors into your projects or into your real-time examples. Then the LEDs, if you want to display some message, the text that is being running up in different colors, you can control that out. 8x8 matrix of LEDs there where you can code and you can show some text that you want to represent. Then string-based problems are there, USB part, and finally the Arduino bootloaders if you want to play with the microcontrollers, if you want to embed your own code inside the chip and you want to start up your own entrepreneurship or startup and you want to have your product being selling out in the market. So you can incorporate your own ISP and the bootloaders. So how you can do so, everything is being there. So go through it, and for the practice part, you can use this Tinkercad program, the Tinkercad interface. This platform has each and every code. Go through their explanation, hardware required, import these all hardware onto the Tinkercad platform, design this particular circuit, and verify the semantic design. That is your design okay, and then go through the coding part. If you are not aware about the coding, simply you can start up with directly copy and pasting this particular code onto the Tinkercad platform and starting with the simulation part and observing your results. So this way you can start working on with Arduino.cc. Later on you can move on with the Arduino cloud part if you want to learn more in the enhanced way.
Participants, are there any queries? Good evening, sir.
Sir, can you hear me?
Yes, I am able to hear you.
Sir, good evening. I am Dr. Preet. So here we are having a course on IoT for our PG students, sir.
Okay.